Hey there, it's Workbench with Workbench Quagmire back with our free code camp Python certification in 100-ish days. It's day 31, and we are starting into a new section here with understanding error handling. And so here we go. What are some common error messages in Python? When writing Python code, it's common to run into errors. Understanding these errors is key to debugging your code quickly and efficiently. These messages tell you exactly what went wrong if you know how to read them. Common Python errors include syntax error, name error, type error, index error, and attribute error. These occur when Python doesn't understand your code or when your logic doesn't match the data you're working with. Here's an example of a syntax error. So our example here is print hello world, and we're missing the last parentheses. So the line is missing a closing parenthesis. Python raises a syntax error because the code doesn't follow proper syntax rules. Here's an example of a name error. So print name error, name is not defined. You're trying to print a variable that hasn't been defined yet. Python raises a name error when it can't find a variable by that name. Type error is an example, or here's an example of a type error. Example code 5 plus the string 5. So unsupported operand types for plus, int, and string. You can add an integer and a string. You can't add an integer and a string together. Python raises a type error when you try to perform an operation on incompatible data types. Here's an example of an index error. So we have an list here, 1, 2, 3, and then we try to print my list 5, and it's clearly out of range. So index error, list index out of range. You're trying to access an index that doesn't exist in the list. Python raises an index error when you go out of bounds. Attribute error. Here's an example. The number 42, which is an integer, and then num.append 5. Well, integers are immutable, so you know you can't change them. So you can't append to them, you can't change them. You can redefine the variable, but you can't change it. The int object doesn't have an append method. Python raises an attribute error when you try to use a method or property that doesn't exist for the data type. So recognizing Python errors messages helps you fix problems faster. Instead of guessing, read the error message carefully. It often tells you exactly what went wrong and where to look. Time for our quiz. Let's see how we do. What does a name error mean in Python? A variable is misspelled. A variable is not defined. I think that one's the second one. Is that true? Index is out of range and data type is incorrect. So it's option number 2. Which error occurs when trying to add an integer to a string? We just talked about that. That is an attribute error, isn't it? No, it's a type error. Sorry. And what causes an index error? A function is missing, a string is not formatted correctly, accessing an element outside the bounds of an iterable. That'd be true. And using an undefined variable. All right, let's see how we do here. All right. What are some good debugging techniques in Python? Debugging is an essential skill for a Python developer. Understanding foundational techniques can help you identify and fix issues efficiently. Debugging is the process of identifying and resolving errors or bugs in your code. It involves examining the code, understanding the flow, and using tools to pinpoint the source of problems. In this lesson, we'll go over common debugging techniques you can use in your next Python project. So using the print function in f-strings. If you watch the series of videos on the project, you saw me do that quite a bit when I was having trouble. So first, using the print function and f-strings in various points in your code can help you understand the flow and state of variables. For example, we have a function add with a and b as the parameters or the attributes. I'm getting that wrong. Result equals a plus b. Print f adding a and b gives us result. Print result. So by printing the values of a and b in result, you can verify that the function behaves as expected. Interacting debugging with PDB module. Next, you can utilize Python's built-in PDB module for interactive debugging. You have to import PDB into your file, and then you put a pdb.setTrace in, and you can examine your code. By setting a trace with the setTrace method, you can step through the code, inspect variables, and understand the program's behavior. If you run the code above, you'll see an output showing the location of the file you're running, the line where you called the .setTrace method, and the code immediately after it, and an interactive PDB prompt. So here's an example of that. If you enter help into the prompt, you'll see a list of commands you can use. So here's what the help documentation looks like. And then you can use the commands to debug your code. For example, if you want to look at the type of elements throughout the code at the moment, you can use the what is command. Example code: what is a class int? So it's what is it's a class int, and what is divide, it's a function divide. As you can see, by the time you run .setTrace, the type of the parameter is an integer, and then divide is a function. And when you continue the execution of the code, you can use continue command or one of its aliases, cont or c. So there's example code, continue, and it finishes and prints our result. Prints divide. IDE debugging tools. Many integrated development environments, IDEs, offer advanced debugging tools such as breakpoints, step execution, and variable inspection. Using VS Code debugger, if you use VS Code, you can set a breakpoint in your code and run the debugger to pause the execution at those points. Here's how to debug the same divide function. Set up your code. Create a file called main.py with the following content. So there's our code. Set a breakpoint. Click in the gutter, the left margin, right next to line 2. Result equals A divided B by B to set a breakpoint. A red dot will appear indicating the breakpoint is set. Start debugging. Press F5 to go to run, start debugging. Select Python file when prompted. A little drop down will pop up. Say, what do you want to debug? The debugger will pause execution at your breakpoint. Hover over variables to see their current values. Use the variable panels on the left to see all local variables. Use the debug console at the bottom to evaluate expressions. Step through the code. Use the debug toolbar to F5 continue, resume execution until the next breakpoint. Step over, executes the current line and moves to the next. Step into, enter into function calls. Step out, exit the current function. So IDE debugging tools provide a visual interface to examine the state of your program, make it easier to identify and fix issues compared to using print statements alone. By mastering these foundational debugging techniques using print statements, the PDB module, and IDE tools, you can effectively identify and resolve issues in your Python code. Each technique has its place. Print statements for quick checks, PDB for interactive exploration, and IDE debugger for visual inspection. So what is the purpose of using a print function in debugging? To execute code faster? No. To display variable values in program flow? Yeah. To compile code? No. Terminate the program? Nope. What does PDB module in Python provide? A graphical user interface? No. A way to compile Python code? No. An interactive debugging environment? Yes. A method to encrypt code? No. What advantages do IDE debugging tools have over the methods like print statements? They let you write code faster. No. They prevent syntax errors. Nope. They fix bugs in your code automatically. No. And they provide a visual interface to inspect the state of your program. That's true. Let's check ourselves. Yep, we're good. we're going to call it a day for now. I would suggest you go play with those things in VS Code or, command line or however you want to use them. But we're well ahead of schedule and we have had some long videos. So we'll do the second half of this tomorrow in day 32. Day 20, today's 32. Yeah, tomorrow will be 32. So we'll get back at it and we'll deal with understanding error handling. So thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you then.